the hydrogen there and another hydrogen there. So this is what we call an amine. All right. Now there is a lone pair of electrons. So this can donate electrons, and then due to that unshared pair of electrons, we say it is basic. Due to that unshared electrons, so like any other, it becomes like a nucleophile. I'm very sure you have interacted with these terms before. That is, they behave like a base, right? So for us to be able to understand it now more, then we need to know how to classify and get to know how we give the name. I hope you can be able to follow that. So amines are classified as either primary, secondary, or tertiary based on the number of carbon containing groups that are attached to the nitrogen. So if we are talking about primary, that means it is only one. So we have and probably we have an alkyl group. So that is 1 degree, what we call the primary. Now for the second degree, it means we have the number of carbon containing groups are 2. So we have the nitrogen, then 2 of the hydrogens are substituted with an alkyl group, like that. In such a circumstance, we say this particular amine is as 2 degree. At 3 degree, it means that 3 carbon containing groups are connected to that. So here we have an alkyl group, of course, with the carbon attached to that nitrogen, and this one, another one. So if you look at it like that, then you can be able to know whether it is a first degree, or 1 degree, 2 degree, or 3 degree. Maybe you can look at examples. Like you look at, in our case here, those amine compounds that have only 1 group attached to the nitrogen atom are primary. If you look at this particular one here, for example, then you can you understand what I'm talking about. 1 degree. So like this one, if you look at the structure of that, you can see there is 1 carbon containing group. This one, there are 2. The secondary, and these ones, there are 3. There are 3 alkyl groups. So you can be able to classify these particular amines depending on the number of carbon containing groups that are attached to that particular nitrogen. We can move on and look for more examples so that can deepen that understanding. Here we have, I don't know whether you can be able to see what is on the screen. All right. But anyway, we can interact through the charts. Like if you pick the first one here, I'm just picking which category of amines is this? A, B, and C, so that see whether we are together. Can use the public chat, communicate. A, B, and C, you can indicate whether it is 1, 2, 3, meaning 1 for 1 degree, for 2 degree, for 3 degree. Yes. And I can see we are quite together. 1 degree primary. So A, I can see majority are saying 1 degree. B, C is that is 3 degree, and that is correct. I think with that one now, I am sure that we are together. Now, once we are done with the classifications, then we go to the naming. The naming, that is the nomenclature, the naming of these amines, the nomenclature. Now, when we go to the nomenclature, we have to follow certain rules. The longest continuous chain of carbon atoms, give us the parent name. Then we change the E, very important, with amine. Like if we can try from here, if it is an alkane, that is an alkane, what we are saying in a nutshell is the E at the end we replace with amine. Replace with amine. So that tells me that we are going to have the alk, the alkan, then we have the amine. The alkan amine, the alkan amine. So then from there, we locate and name any subsequent groups, keeping in mind that the chain is numbered away from the amine group. So here, the amine group becomes our functional group. So that becomes our functional group. So naming will always start from the carbon next to amine functional group. We're going to see a few examples so that we can appreciate that. There is a point here, and I want you to note that if a subsequent group is attached to the nitrogen atom instead of the carbon, then we design, or that one is designated as N. Kindly note that one somewhere because I don't want to repeat that particular point there, that if secondation, if the substrate group is attached to a nitrogen, then we designate or we assign that particular substrate group as N. We can have a few examples. We have a few examples so that we can deepen that. All right. So, for example, we have these examples here. We have these examples here. You can see the first one. It has only one carbon atom. This carbon atom here. Attached to that nitrogen. So in terms of, we can just call it N-methamine, methamine, metha, the word methyl, amine. Then you add the amine at the end, the name for that one. So here, because there is only one carbon that is attached to that, so this one becomes our parent name will come from that. So there are two carbon atoms. So we are having two ethylamine. But now you can see along this chain, this being the first carbon atom, there is this methyl group. The same carbon atom, there is this methyl group. So this one is on the carbon chain, and that's what we are saying. For this one is 1,1-dimethyl ethylamine or ethylamine. If you look at this one now, the parent name goes with the carbon chain, the longest continuous carbon chain attached to that particular. As you can see there, we have the two carbons there. So from the word al, that is the alkyl, that is alkan amine, alkan amine. So what we are going to do is that now, depending on the number of carbons, like if we substitute with S, like that. So for our case here, we're going to have ethylamine, ethanamine, that is from the word alkan amine, substitutes the number of carbons which are 2. But you can see now there are those that are attached to the same nitrogen. So they are saying, depending on how many they are, so there are 2. NN, di means there are 2. Dimethyl ethanamine. If you look at this, there are those that has a common name, like if there is an amine connected to a benzene ring, we call it aniline. So in such a circumstance, we say that this one now becomes the parent name. So you can see now the whole of this becomes the parent name. There is a methyl group there attached to this nitrogen. So we have N, which is only one, methyl aniline. So the whole of this is aniline. Again, we have this one is an aniline on its own, but we have 2 methyl groups attached to that particular nitrogen, and therefore we call it the NN dimethyl aniline. The NN dimethyl aniline. The NN dimethyl aniline. Now, we need to look at another property of these amines. And one thing you should note is on the aspect of the unshared electrons. Cindy, I'm hoping we are still together.
Yes.
All right, it's good to confirm. Now we talk about why the amines are basic. And we are saying that amines are basic because they possess unshared electrons. Okay, that means they can give out the electrons. We can share those electrons to other atoms. And there's a point here that says that the greater the electron density, the more they are, the more basic they are. So groups that donate or supply electrons will increase their basicity, because we are going to increase the electron density. So basically this one, we are talking about this point, that if we increase the electron density, then we increase the basic nature of that particular substance. And when you decrease the density, when you decrease the electron density, then you end up kind of doing those electrons. And the electron density around the nitrogen will of course decrease, meaning it will be less basic. Now, there are those species or branches that increases the number of electrons, like alkyl halides, where the more they are, like here we have 3 of them. You see that? Look at this one is we have 3 methyl groups. 3 methyl groups. So what happens? These methyl groups, they contribute electrons. Therefore, they end up increasing the electron density. So kind of note, the methyl groups increases the electron density. Therefore, as you can see, this particular one here is the highest in terms of the basic properties. What about the unsubstituted ammonia? Yes, it is still basic, but lower in terms of the strength of gates. Now, when it comes to in aqueous solution, talk about aqueous solution. Now, what happened is it's supposed to be the reverse. I think there's a mistake here. Let me just try to. So of course, it reverse. For some reason, I'm going to explain. So this one becomes the most basic. The other one becomes the least basic. And the reason is, of course, you know that ammonia is actually polar, highly soluble. So what happens is it attracts water. It attracts water, forming what we call hydrogen bond. So this one is in hydrogen bonds. Other one here. Let me just do it properly. Like that. we have that force of attraction. So in the process, you are introducing this electron donating. These are what we call the electron donating. And remember what we have said about electron donating. They increases the electron density. It increases the electron density and therefore becomes more basic. So you can see in solution where you are introducing water there, why there is the change in terms of the basic properties of that particular group or molecule. That explanation is stated here, and I'm hoping that you can be able to understand now from that point of view that the amines in water solution exist as ammonium ions, but the most important point I wanted us to really emphasize is that in water, the ammonium salts of primary and secondary amines will undergo what we call the solvation through hydrogen bonding to a much greater degree than the ammonium salts of tertiary amines. This solvation will introduce the water molecules. The water molecules are rich in electrons, and therefore, when you increase the electron density of that particular amine, then you end up increasing the electron density. So it is always good to know why it is basic nature and why it is weak. Apart from that, there is the aspect of resonance that makes those electrons unavailable. The resonance makes the electrons unavailable, and therefore it reduces its electron density, and therefore the basic properties of that particular molecule. So like in this case, according to these statements I put there, these when you're talking about the amines that are connected to aromatic rings, and why they are weaker in terms of basic properties is because of the resonance. Resonance means electrons keep on shifting from one point to another, and that one makes it now difficult for them to be available, to be used, or to be donated. So the delocalization of the unshared electron pair occurs through the ring, making these electrons unavailable. A very important point to note, unavailable for the reaction. Unavailable for the reaction. So having the background of what we are going to discuss, how do we prepare these amines? How do we prepare these amines? There are various ways of preparing the amines. We are going to describe just a few of them so that you see how we are getting that. The one that is the most important in this case is what we call the alkylation of ammonia. The alkylation of ammonia. I want to use an example for this so that you can understand what we are talking about. When you talk about alkylation, basically, we are talking about introduction of an alkyl group. Introduction of an alkyl group. That is the alkylation. Alkylation. Like for example, here we are having the reaction between, let me say generally that's alkyl halide, and you are reacting with ammonia. We just put it like that. Right? So remember what we said about the ammonia. It has lone pairs. So what happened, like in the other previous case, we end up having this being partially positive, and the partially negative becomes a very good leaving group. So this one has donated electrons. So that tells us that here we are having now our amine, that is ammonia. That is ammonia. Remember, this one has given out electrons, so it is positively charged. Now that the alkyl group has been introduced, N plus the chloride, because in the process we expect the chloride, not the chloride as well, that one should be the halide. The halide. So allow me just to use the way it was. To say this one is, but remember this one can either be chlorine, can either be chlorine, can either be iodine. So those are halogens. Those are halogens. Now what we have done basically here is to have introduced a positive charge which we need to eliminate. So what happened now here with this particular chloride, that is the halide, for us to be able to balance like that, then we have already substituted one hydrogen. And therefore we end up getting we have now two hydrogens remaining. So that's an amine. And remember, the procedure can continue to substitute this hydrogen and this hydrogen. So we end up getting the NNN by, of course, substituted amines. All right? So in such a circumstance, again, there is a lone pair. Yes. So when we have more of alkyl group, allow me just to put that one so that we can differentiate with the other one. The same case applies. So you end up having this one is taking longer to type, but those are lone pairs of electrons. So remember, this one has given out electrons, so it becomes positive. So again, in the presence of another halide, we need to balance the charge. So we end up having only one hydrogen. That is, now you prepare secondary amine. Then after this, we can continue So now here what we'll be getting is the X like that. So that now again this one you can see we still have the hydrogen. When you have it like that, the lone pairs end up reacting with more. Remember these ones are first there, like that. So again, the same procedure. And this becomes a very good living group. So the final products you end up getting that. So this one is positive. Plus, so there are two, sorry. Allow me to say this one is just the two plus the chloride. Again, this one sorry. So we have introduced the third one, sorry. So the first one we did have the charge, this one was 2. Then the other one, now I can say here we have 2. This is positive. We need to balance the charge because that hydrogen, and then the charge complete. Basically what we are saying is that we can end up having up to a tertiary amine. So this nitrogen here we have the hoping that point are clear. So can we let me see from the chart whether it is clear. If I can see a few students confirming what we have discussed there. So that is an example of how we prepare the amines. That is using what we call that is the reaction between ammonia and alkyl halides, where the alkyl halides give us good living group. Another way of preparing that is the amines is through reduction, the reduction of nitriles. That is one of my favorite because it's very easy to understand. When you're talking about reduction of nitriles, allow me to use the whole of this is just R. So basically, you're talking about the group there. So the first thing is to understand the structure of this particular lithium aluminium hydride. Lithium aluminium hydride. You can remember the history. This is a salt with lithium. The salt with lithium and aluminium hydride. aluminium hydride, an overall charge. I'm just interested in this bit of that reducing. Let us go to the genesis. This one is aluminium. Aluminium has a charge of 3 positive. And these are hydrides. One hydride there. There are 4 of them. These are negatively charged. Like that. Like that. So what happened is, the first thing is to balance the charge. This negative, and this negative. It realizes those 3 positive. So that's why you see from this, we have only one excess negatively charged hydrogen. And this is now, we use it basically as a hydride. So you can just represent it as that. So now in a complex. So when you talk about now aluminium, now you understand why we are. This one is that. So if I put a negative there, you understand. So you pick one of the hydrogen. So remember, this one is carbon partially positive. This is partially negative. So this one will attack with that particular carbon, opening this. And hopefully you can see that move. So what we'll be having here, we are having the R. Now this carbon, remember we have broken one. So we end up having, this one is negatively charged. So we produce a hydrogen there. All right, like that. So when we have now the acid, after here, we end up having now introduced so this one becomes a nucleophile. Nucleophile attacks on this electrophile here, so that now you can balance those charges. Right? So you end up getting now also very good in terms of typing speeds, but the most important thing is to understand. So that is what you have. Remember, we want an amine. Again, this one becomes, this is like a double bond, becomes partially positive, becomes partially negative. In the presence of another hydride, now you understand if I put it like that, you understand where it is coming from, one of these. So this one is added here. This one opens. And I can draw it just here, say R, this C, as hydrogen, has another hydrogen because you have introduced the 2. So remember there is this and this. So now there are 2. Break the bonds. This particular nitrogen here has 1 hydrogen, but remember it has gained these electrons here. Therefore, it is negatively charged. And when it is negatively charged, with an introduction of hydronium ion, end up having this is positive, that having that kind of a mechanism. So what are we going to have? We have C with the H there, H there. Then here we have the N now. The N, we have the two hydrogen. So that means you end up getting your amine. I don't know whether that one is clear. Let us communicate whether it is clear. Yeah. With that in mind, then we can move on. Move on. Then the other one is reduction of amides. Reduction of amides. That is the next. So we look at the mechanism also for this. The mechanism for this. You see how to go about it. Now for this, it is similar to what we have said. Let me see how you can simplify it. Now for this, maybe I can use, let me use this space so that we don't, can use that space. Now, when you're reducing the amides, allow me to use the whole of this as an R because I'm only interested in this functional group here. So we have the R, T, double bonds. Then we have the NH2, like that. So the first thing we usually have here, because there is a hydroxonium ions, like any other carbonyl, is the activation of this high oxygen. So if I put, let me just squeeze it there so that we don't take a lot of space, right? So if I put that hydroxonium ions in here, that is the hydroxonium ions. So which is, of course, it is positive. So what happened is the activation of this. So this one, the balance the charge there. So what we are going to have is this one is very important. We have the double bonds. This one has doubts. This one becomes positive. That's positive. Then we have This remain intact like that. So with the hydride now, so remember we have talked about hydride from our reducing agents. So this one opens. You can be able to see that. So that now you end up having let me just remove this space so that you can continue with that discussion there. So with that introduction then, what are we having? We have our alkyl group. Now there is formation of OH there. So we have already introduced the hydrogen there. So remember this hydrogen is from the hydride. Then our amine there, amine remain like that. So we continue activating we continue activating our OH here. Remember we're interested with our amine. So in the presence of hydroxonium, so again what happened here is that we have this particular oxygen here. Balance that. So what you're going to have now here, we're introducing a living group. Introducing a living group. We have a carbon now. This particular oxygen has the two hydrogens. Remember, this one has given out the electron, so it becomes positively charged. This one has a hydrogen. And then we have the amine, like that. So from here now, ladies and gentlemen, because this one is a good living group, the lone pairs from this nitrogen forms a double bond, so as this becomes a good living group. With that in mind, there is formation of double bonds. The double bonds, that is carbon, the one hydrogen, double bonds. Then we have our, so this one again has given out the electrons, so it becomes positive, like that. So in the presence of a hydride, again, let me just use it in full. So we end up having aluminium hydride, aluminium hydride, aluminium hydride, aluminium hydride. So remember, overall is negative. So we remove that one. Remember, this is partially positive, so that this one can be balanced like that. So what we are going to have is the double bond is already broken. We end up having this carbon. We've already introduced a hydrogen and another hydrogen. Yes. Then you end up having a single bond. Then you are NH2. So remember, this one now is again a primary 1 degree alkyl amine. I don't know whether that one is understood. Let us continue interacting. There is somebody who is not hearing. I don't know whether you can confirm that, Cynthia.
Yes.
Cynthia, are you still there?
Yes.
Yes, so probably if somebody is asking where is H minus coming from, I thought I had already explained where it is coming from. Aha. That is okay. Thank you, thank you. So basically, for those who are asking, hydrate is coming from aluminum hydrate. That's what I said. All right. The rest you can confirm whether you are able to follow that. Very important. Maybe what we can do, because I can see people asking some questions there, instead of doing everything today, we can stop there. Let us first of all digest preparation of amines. Then we can look for another day where we talk about the reaction. I don't know whether that one will be fair enough. Yes, so Cynthia, I think we can still prepare another online 1 hour on Monday, right? Can we have it on Monday as from 11?
Monday we have classes.
You have?
Classes and CAT.
So at what time can we have another 1 hour? Maybe we can agree with the members and then let me know.
Okay.
So the CAT will reach up to this point, so we should